Hi there, I'm Tom Paperkamp, a platform product owner, back with a bonus episode in our platform engineering series. We've journeyed through the evolution of DevOps, demystified internal developer platforms, embraced the platform as a product mindset, and charted the course from vision to goal. But what if the structure of our teams is fundamentally shaping or hindering our technical architecture and flow? Today, we're exploring the inverse Conway Maneuver, organizational design for fast flow. We'll unpack the famous Conway's Law and see how our communication paths dictate our system designs. Then, we'll explore how to flip this law on its head. Can we intentionally design our teams to achieve the architecture we need? Along the way, we'll touch on why some setups feel like a frustrating man behind the curtain from The Wizard of Oz, how we can aim for the reliable self-service of a vending machine and ultimately pave a smooth yellow brick road for our developers. How do we engineer our organization for success? Let's dive in. Let's kick things off by understanding the foundation, Conway's Law. Back in 1968, computer scientist Melvin Conway made a profound observation about the relationship between how we organize ourselves and what we build. His original wording was, any organization that designs a system, defined broadly, will produce a design whose structure is a copy of the organization's communication structure. Think about that for a moment. It suggests that the way our teams talk to each other or don't talk to each other inevitably shapes the architecture of the software we create. This law implies that if your organization is structured in functional silos with walls between teams, the systems you build will likely mirror those silos, making smooth end-to-end flow incredibly difficult to achieve. While it's an observation from 1968, this mirroring effect remains a powerful lens to understand why certain organizational structures persistently create friction in modern systems. It helps diagnose problems, even if the solutions lie in more recent principles. Now, if Conway's Law tells us that our organizational communication structure will be mirrored in our system design, what happens when we try to ignore that reality? The authors of Team Topologies identify several common obstacles that prevent teams from achieving a fast flow of change. Look at this diagram, taken directly from their book. Notice one key obstacle listed right there, pushing against Conway's Law. This means trying to force a system architecture that fundamentally clashes with how your teams are structured and communicate. It's like trying to fit a square peg into a round hole. When the natural communication pathways don't support the desired architecture, you introduce friction, dependencies, misunderstandings, and delays. You're essentially swimming against the current, and that inevitably slows things down, blocking the smooth flow we're aiming for. It often underlies many of the other obstacles you see listed here. This comic hits the nail on the head, doesn't it? If Conway's Law holds true, that our communication structures dictate our system design, and management is responsible for defining those structures, well, the punchline follows logically. Management ends up designing the software architecture whether they realize it or not. This brings us to a crucial point. The role of engineering managers, and indeed all leadership involved in organizational design, extends far beyond traditional people management. The way they shape the teams, define their boundaries, and influence their communication patterns, the team of teams structure has a direct and profound impact on the success, maintainability, and adaptability of the digital products being built. It's organizational engineering with significant technical consequences. So, if management inadvertently designs our architecture through organizational structure, how should we respond to this reality? Martin Fowler outlines 3 main approaches on his website. First, you could simply ignore Conway's Law. Maybe you haven't heard of it, or perhaps you think it doesn't apply. Narrator, it does. Fowler notes, the first step in dealing with Conway's law is to know not to fight it. This leads to the second option, accept it. Recognize its impact and consciously design your architecture so it doesn't clash with how your teams naturally communicate. As Fowler says, accepting Conway's law is superior to ignoring it. But there's a third, more proactive, and often recommended option, the inverse Conway maneuver. This is where we intentionally change the communication patterns and team structures first to actively encourage the desired software architecture. Instead of letting the org structure dictate the system, we design the org structure to enable the system we want. Let's delve deeper into this powerful maneuver. So, how do we actually use this inverse Conway maneuver? It's all about intentionally taking advantage of the mirroring effect that Conway's law describes. Now, let's start a brief history lesson here, because this isn't just a recent idea. Research has backed this up for quite some time. Way back in 2012, Alan McCormack and his colleagues highlighted this dynamic, stating, products tend to mirror the architectures of the organizations in which they are developed. This dynamic occurs because the organization's governance structures, problem-solving routines, and communication patterns constrain the space in which it searches for new solutions. In other words, the way we're set up limits the kinds of solutions we can even think of. Therefore, to increase our chances of building truly effective software systems optimized for that end-to-end flow we desire, we can undertake an inverse Conway maneuver, sometimes called the reverse Conway maneuver. The core idea is to intentionally reconfigure the team intercommunications before the software is finalized. The inverse Conway maneuver implies that we should actively design our teams to match the software architecture we need. Now, our history lesson continues. While the idea of influencing architecture through organizational design was gaining traction, the specific term inverse Conway maneuver got a significant boost when it appeared on the ThoughtWorks technology radar. Back in July 2014, in Volume 10, ThoughtWorks explicitly added the inverse Conway maneuver, placing it in the trial ring, signaling it as something companies should consider experimenting with. This marked a notable recognition of the concept within the industry. However, the inverse Conway maneuver's official stay on the radar was relatively brief. As you can see, it appeared again in the January 2015 edition, still in the trial ring, with the same description emphasizing evolving team structures to promote desired architecture. But after that, it dropped off the radar editions. ThoughtWorks explains they don't have the bandwidth to continuously review all the blips. So, while impactful, its time as an explicitly tracked item on the influential radar was limited to those two appearances in late 2014 and early 2015. So, the inverse Conway maneuver, ICM, faded from the official radar listings after early 2015. But fast forward to May 2023, and look what popped up on the ThoughtWorks Insights blog, a dedicated article titled Inverse Conway Maneuver, How to Speed Up Product Development Teams Successfully. Why the revival? The blog post argues that in today's complex world, with increasing pressure for speed and customer centricity, consciously designing teams around product value streams, a core application of the ICM, is more critical than ever to reduce dependencies and accelerate delivery. It's essentially framing ICM as a key enabler for modern product development effectiveness. Our brief history lesson now brings us closer to the present day, where the ideas underpinning the inverse Conway maneuver became integrated into industry-shaping research and frameworks. Dr. Nicole Forsgren and her colleagues discussed its importance back in 2018 in their foundational book, Accelerate, based on years of rigorous research analyzing what makes high-performing technology organizations tick. They state, our research lends support to what is sometimes called the inverse Conway maneuver, which states that organizations should evolve their team and organizational structure to achieve the desired architecture. The goal is for your architecture to support the ability of teams to get their work done, from design through to deployment, without requiring high bandwidth communication between teams. This highlights a critical objective, designing both our architecture and our organization so teams can operate more autonomously, reducing the need for constant time-consuming communication and coordination across team boundaries. And that concludes our look back. This powerful approach, validated by Accelerate's research, truly gained widespread traction and became more practically understood with the release of the Team Topologies book in 2019, which builds heavily on this principle of intentionally designing organizations for better software systems. So, how does this inverse Conway maneuver fit into the broader picture we've been painting? In our first video, we explored why platform engineering is the natural evolution of DevOps, discussing how it addresses the cognitive load and flow challenges that often emerged as DevOps matured. Now, we'll connect those ideas directly. We'll explore how intentionally designing our organization, applying the inverse Conway maneuver, is crucial for unlocking the full potential of both platform engineering and the original goals of DevOps. If you haven't watched that introductory video yet, I highly recommend checking it out first, as it lays much of the groundwork for today's discussion. Alright, ready to dive deeper into how different organizational structures impact our flow? Let's look at some common DevOps team setups. To understand how different organizational structures impact flow and architecture, it's helpful to look at established patterns. Back in 2013, Matthew Skelton published the original DevOps topologies patterns, which have since become a standard way for the industry to discuss the pros and cons of various team designs for software delivery. You can see here a range of both antitypes, structures likely to cause problems, and types with varying potential for success. The DevOps topologies collection helps organizations analyze these different patterns and improve their software delivery and operational capabilities. As Matthew Skelton stated, by exploring the strengths and weaknesses of these team structures, or topologies, we can identify the team structure which might work best for DevOps practices in our own organizations, taking into account Conway's law. So, let's use this framework and have a look specifically at the topologies considered to have high potential. Okay, looking at the DevOps topologies, two patterns stand out with high potential effectiveness. Type 1, Dev and Ops collaboration. Here, development and operations teams work closely together, maintaining separate team structures but fostering strong communication and shared goals. Type 2, fully shared ops responsibilities. This model goes a step further, embedding operational responsibilities directly within the development teams. It's the classic you build it, you own it approach, fully realized. Notice the visual representation for both Type 1 and Type 2. The circles representing Dev and Ops are overlapping. This isn't just a coincidence. That close integration and shared space are fundamental to why these topologies are considered highly effective in the original DevOps model. They represent the ideal of breaking down silos and fostering deep collaboration. But does high potential come with its own challenges? Let's see. Each service must be fully owned by a team with sufficient cognitive capacity to build and operate it. Remember that sentence from our DevOps evolution video? It embodies the "you build it, you own it" DevOps mantra, linking true responsibility and mandate to the necessary knowledge and cognitive capacity required. Without responsibility, we saw how we get the broken DevOps scenario, tossing work over the metaphorical wall of confusion. The collaborative high-potential topologies like Type 1 and Type 2 aim to tear down that wall. But removing the wall often shifts the pressure onto the knowledge aspect of ownership. We expect teams to be cross-functional and handle everything end-to-end. But as we discussed, the modern ops landscape is incredibly complex. This creates a new constraint, the sheer cognitive load of being knowledgeable across the entire stack. Furthermore, as teams grow, communication overhead explodes exponentially, making deep knowledge, sharing and alignment incredibly difficult. Think Dunbar's number, limiting effective close collaboration. Expecting a single team to master and effectively communicate across two broader domains inherently strains their cognitive capacity. This isn't a new problem. Back in 2015, Peter Newmark accurately pointed out, despite striving to be cross-functional, one of the thornier problems product teams often face is lacking some necessary competence. So, we arrive at a crucial realization. The very DevOps topologies identified as having the highest potential for effectiveness, those deeply collaborative models, often come hand in hand with the highest cognitive load for the teams involved. It's a direct consequence of expecting teams to own and know everything end to end in today's complex environments. So, we have this inherent tension. Team autonomy, which increases flow by reducing handoffs, often clashes with the lack of deep, specialized competence across the entire required stack, which decreases flow. The reality is, there's no silver bullet here. It forces a trade-off between end-to-end responsibility, granting teams full autonomy, and managing the cognitive load that comes with expecting deep end-to-end knowledge in every domain. I recently fell in love with this phrase from Esther Perel. A paradox to manage, not a problem to solve. And I think it applies perfectly here. There might not be a way to completely eliminate this tension between broad responsibility and deep knowledge. Instead, we need to find ways to manage the paradox, navigate the trade-off, and balance the polarity effectively within our specific context. So, how do we actively manage this paradox? One useful tool is polarity mapping. It helps us visualize and navigate dilemmas that are ongoing, seemingly unsolvable, and contain opposing yet interdependent ideas. Let's look at this polarity map tailored for our DevOps situation. On the left pole, we have high responsibility, end-to-end. Think you build it, you own it. The upsides are clear. Faster feedback, reduced handoffs, increased ownership, better collaboration, and potentially higher velocity. But the downsides, the unintended consequences, are significant. Cognitive overload, potential burnout, inconsistent standards, difficulty scaling expertise, and the risk of errors due to a lack of deep knowledge everywhere. On the right pole, we have high knowledge, specialized, reminiscent of the older siloed world. The benefits? Deep expertise, optimized performance, standardized practices, and potentially higher quality. But the downsides are equally familiar. Siloed information, slower changes, bottlenecks around experts, and reduced adaptability. The tension is clear. We want the upsides of both poles, the autonomy and speed of end-to-end responsibility and the quality and depth of specialized knowledge. We want to achieve our greater purpose, shown at the top, increase flow. And we want to avoid the downsides of both poles, which lead to our fear at the bottom, decrease flow. How does this map help us find a way forward, especially towards platform engineering? It starkly highlights the negative consequences of pushing too hard on the high responsibility pole without support, particularly cognitive overload. This visually demonstrates why many teams get stuck. It makes the case for needing mechanisms to mitigate those downsides. This is precisely where concepts from Team Topologies like a platform team providing curated self-service capabilities, come in. Such a platform aims to offload specific cognitive burdens, like infrastructure complexity or security tooling, allowing stream-aligned teams to retain high responsibility for their core domain while benefiting from specialized knowledge embedded in the platform. It helps us manage the polarity, keeping us in the upper quadrants. Suggestion: this map is a powerful diagnostic tool. To make it even more actionable, you could use it in workshops to add specific action steps. How do we get more benefits of both poles? And early warnings. What are the signs we're slipping into the downsides? So, we've identified these highly collaborative DevOps topologies, Type 1 and Type 2, as having the highest potential effectiveness according to the original patterns. They embody the DevOps ideal of breaking down silos. However, as we just discussed, this high potential often comes with a significant downside: high cognitive load. Teams are expected to know and manage everything end to end. And this cognitive load is precisely why many organizations find themselves stuck in the middle, as highlighted in the 2021 State of DevOps report. Teams adopt these collaborative structures aiming for high performance, but the sheer weight of managing the complexity, the tools, the infrastructure, the security, the operational tasks prevents them from truly accelerating. They hit a plateau because the cognitive burden slows down value delivery, increases the chance of errors, and hinders their ability to focus on innovation. They have the potential to be high performers, but the cognitive load keeps them stuck. Now, it's fair to say other factors like chronic underfunding, technical debt, or shifting priorities can also contribute to teams getting stuck. However, the intense cognitive load directly linked to the complexity these high potential collaborative structures must manage represents a critical bottleneck that organizational redesign strategies like platform engineering specifically aim to alleviate. Viewed through the lens of Conway's law, the organizational design itself becomes the constraint that causes many DevOps initiatives to get stuck in the middle. Pushing for high collaboration without addressing the resulting cognitive load creates a bottleneck inherent in the structure. To break free, we can't just focus on tools or processes. We have to make Team of Teams design part of our strategic plan. We need to actively use the mirroring effect of Conway's law to our advantage with an inverse Conway maneuver. So, how do we start designing our organization for better flow? Niels Flagging, in his book Organize for Complexity, offers a key insight. The key to successful knowledge work is in the interactions between the informal structure and the value-creating structure. This suggests that our focus shouldn't just be on formal org charts, but on how teams actually interact based on the real needs of delivering value. This aligns perfectly with the Team Topologies approach, which advocates starting with stream-aligned teams, those focused directly on a business domain or organizational capability. Understanding their value-creating structure and their real interaction needs, the informal structure, is the crucial first step of our inverse Conway maneuver. But, as our polarity map showed, simply aligning teams to value streams runs into the trade-off between the scope of their responsibility and the cognitive load imposed by the required knowledge. How do we manage that? It's time to extend our inverse maneuver and apply another team topology, platforms, designed specifically to reduce cognitive load through clear boundaries and well-defined services. So, how can we approach these potentially significant organizational changes, like applying the inverse Conway maneuver, in a structured way? The Lean Value Tree, LVT, which we touched upon in the Vision to Goal video, offers a fantastic framework. It helps us visualize our strategy cascading from a high-level goal down through testable hypotheses or bets to concrete initiatives. Crucially, The LVT allows us to treat organizational design changes not as disruptive Big Bang reorganizations, but as controlled experiments via testable hypotheses. We are essentially saying, we bet that changing our team structure or introducing a platform team will lead to this specific, measurable outcome. Let's look at two examples. Example 1, value stream alignment. The goal here is clear: increase time to market speed. The hypothesis or bet is a classic inverse Conway maneuver focused on value streams. If we reshape teams around value domains, we'll reduce dependencies and lead time. The initiatives, mapping domains and piloting a cluster team, are the first concrete steps to test this bet. We measure success by tracking lead time, waiting time, and the ratio of self-reliant backlog items. This directly relates to that first step we discussed, aligning teams to the value-creating structure. Example 2, platform team introduction. Here, the goal is potentially to increase product margin. The hypothesis links directly to the second step of our maneuver, offloading cognitive load. If we establish a self-service platform, we'll reduce cognitive load, free up time for innovation, and thus improve margins. The initiatives involve growing the platform team and onboarding an internal customer. Success is measured through product P&L, the number of successful experiments, and the ratio of technical versus non-technical tasks for the value stream teams. Using the LVT, we frame organizational engineering as an experimental, iterative process, allowing us to learn and adapt quickly, ensuring our changes are tied to tangible business goals and validated by measurable outcomes. Crucially, while the ultimate goal is business impact, like faster time to market or higher margins, we should also define leading indicators to measure the success of the organizational change itself. Are inter-team dependencies actually decreasing? Is cognitive load perceived to be lower? Tracking metrics like dependency counts, types, resolution times, or even team sentiment surveys can give us much faster feedback to de-risk the change and adapt the initiative well before the final business outcome fully materializes. So, how do those structured experiments from the lean value tree help us tackle common organizational dysfunctions? Let's look at a typical scenario. On the left, we see what often happens in organizations with traditional silos, even if they try to put a modern API or portal on top. It looks like self-service, like the magical machine of the Wizard of Oz, but behind the curtain, it's still just manual handoffs between different teams, Wintel, DBAs, middleware. This is TicketOps disguised. The result? Coupled backlogs, long lead times, and frustrated developers who don't have true self-service. It's an artificial cloud relying on the man behind the curtain. Now, contrast that with the image on the right, the vending machine. This represents the goal: genuine self-service infrastructure as a service or platform as a service. Developers can instantly get the resources they need predictably and reliably, without hidden manual steps or complex dependencies. The inverse Conway maneuver, guided by hypotheses tested through the LVT, is the engine for this transformation. By intentionally redesigning team interactions, perhaps by creating a dedicated platform team focused on automation and providing genuine self-service capabilities, like the initiatives in our LVT examples, we can dismantle the man behind the curtain setup. We replace the slow, opaque, handover-driven process with a fast, transparent, automated vending machine, enabling true developer autonomy and faster flow. The transformation from the hidden complexity of the Wizard of Oz to the clear self-service model of the vending machine relies on establishing clear boundaries and responsibilities. This brings us back to a concept we touched upon in the DevOps evolution video. Good fences make good neighbors. This phrase, highlighted in Hannah Foxwell's presentation on shifting left, the right way emphasizes the need for well-defined interfaces and ownership between teams or layers. These fences are key to managing cognitive load and enabling flow. Before we explore the fences needed to truly escape the middle with high-performing setups, let's first look at some common medium potential topologies that represent a significant step forward from traditional silos, often forming the foundation. Let's look at how these medium potential topologies build some of those necessary fences. Here we see type 3, Ops as Infrastructure as a Service, IaaS. The Ops team essentially provides the underlying infrastructure, compute, storage, networking as a consumable service to the application teams. Think of it as providing the basic building blocks. And type 8, container-driven collaboration, often implies a platform as a service and PaaS model, where the Ops or platform team provides a container orchestration platform like Kubernetes and related tooling as a service. Application teams deploy their containerized applications onto this managed platform. In both cases, the Ops/platform team abstracts the complexities of the underlying layer and offers it as a service. This aligns perfectly with the SaaS, Everything as a Service interaction mode described in Team Topologies. The platform provides, the application team consumes. The core goal here is cognitive offloading. The burden of managing raw infrastructure or the intricacies of Kubernetes is shifted away from the application teams and onto the specialized platform team. This frees up the application developers to focus higher up the stack. And this self-service access to standardized infrastructure or platform resources, that's our vending machine in action. Developers can get the compute, storage, or container runtime they need on demand without needing to know how the machine itself is built or maintained. Now, having an Ops or platform team provide infrastructure or containers as a service, like our vending machine, is undoubtedly a huge step forward compared to traditional Dev and Ops silos. These Type 3 and Type 8 topologies establish crucial fences, enable self-service for foundational resources, and definitely help reduce some cognitive load for application teams. However, are they enough to truly escape the stuck in the middle phase? Often, the answer is no. Why? Because while these topologies offload the burden of managing the lowest layers of the stack, the raw infrastructure or the container platform, they often don't address the complexity that sits just above it. Application teams still need to figure out CI/CD pipelines, testing frameworks, security scanning, observability setup, secret management, database provisioning, and potentially much more. These reusable IaaS or PaaS building blocks don't automatically solve the operational challenges related to the application lifecycle itself. Significant cognitive load related to gluing services together, configuration, and operational best practices remains squarely on the shoulders of the application teams. Therefore, while valuable, these medium potential topologies often don't provide enough cognitive offloading across the full development and delivery lifecycle to propel teams into the high-performing category. The remaining burden keeps them, stuck. So, if the vending machine of basic IaaS or PaaS isn't enough to fully unblock our teams, what's the next step in our inverse Conway maneuver? We need to build another higher level fence. Look at this diagram, again inspired by Hannah Foxwell's presentation, but now showing all three distinct layers: infrastructure, platforms, and applications. This middle platform layer is where we can introduce a true internal developer platform, IDP. Of course, the success hinges on this being a well-designed and maintained IDP, built with a product mindset, something we explored in the Platform as a Product video. A bad platform can indeed hinder flow. An IDP, built and maintained by a dedicated platform engineering team, goes beyond just providing infrastructure building blocks. It offers curated, self-service workflows and tools, the golden paths, that guide developers through common tasks across the entire software development lifecycle. Think CI/CD testing, deployment strategies, observability, security scanning, all packaged and presented in a consistent, easy-to-consume way. If we want to stick with our OS metaphors, while the infrastructure layer might provide the basic vending machine for resources, the IDP layer paves the smooth, well-lit, yellow brick road for developers to follow, drastically reducing their cognitive load and enabling them to focus on delivering application value. This is how we truly empower stream-aligned teams and help them escape the stuck-in-the-middle plateau. Now, a quick but important clarification. The term platform can be a bit overloaded. We've seen platform as a team topology, like Type 3 ops, providing IaaS, often operating at the infrastructure layer. Here, we're also talking about the technical layer itself. In this case, the IDP, built by a dedicated platform engineering team, which sits above the infrastructure. It's crucial to distinguish between these concepts when designing our organization. So, we have these distinct layers: infrastructure, platforms IDP, and applications. A key principle, building on the good fences idea, is applying the "you build it, you own it" DevOps mindset within each layer. The infrastructure team owns the SS/PaaS services they provide via a well-defined SaaS/everything-as-a-service interaction mode. The platform team owns the IDP and its golden paths offered via another clear SaaS interface. And the application teams own their applications built on the platform. Each layer operates with autonomy and responsibility for its domain. Applying the inverse Conway maneuver effectively often involves intentionally designing these interactions to minimize costly, high-bandwidth collaboration and instead favor efficient SaaS or targeted facilitation modes depending on the context and maturity of the services. How do we get there? Implementing a full-fledged IDP on top of a robust IaaS/PaaS layer can be a significant undertaking. Therefore, a phased approach often makes sense, especially when applying the inverse Conway maneuver. Phase 1. Establish the foundation, IaaS/PaaS. Focus first on building the reliable vending machine, automating infrastructure provisioning and offering basic IaaS or container platform-based PaaS capabilities as self-service, like DevOps topologies, Type 3 or 8. This involves creating a capable infrastructure or platform team focused on this layer. Phase 2. Build the IDP. Once the foundation is solid, build the IDP layer on top, creating the yellow brick road with golden paths, CI/CD, observability, etc., managed by a dedicated platform engineering team, potentially evolving from or collaborating with the initial infrastructure team. What are the trade-offs of this phased approach? Pros. It breaks down a massive change into more manageable steps, reducing risk and the initial cognitive load for the platform builders. It allows the organization to learn and iterate. It delivers incremental value sooner, as even basic IaaS/PaaS self-service is often a big improvement. Cons. It takes longer to realize the full benefits of a comprehensive IDP. Application teams might remain stuck for longer, dealing with complexities above the IaaS/PaaS layer. There's also a risk that the organization stops at phase 1, deeming the vending machine good enough, never reaching the full potential of the yellow brick road. Remember our discussion in the From Product Vision to Product Goal video, particularly regarding on-premise environments? We highlighted the critical need to fix the infra first. Often, especially on-prem, that reliable, automatable IaaS layer, the vending machine, simply doesn't exist. In such cases, building that foundation must be the priority before attempting to build a sophisticated IDP on shaky ground. Trying to build the yellow brick road without solid ground underneath leads to frustration and failure. This all requires investment, but the aim is to consolidate efforts currently fragmented across many teams, reducing overall waste. Success also depends on well-managed interfaces, those good fences between the layers. This journey, from recognizing the impact of Conway's law to managing the responsibility knowledge paradox to intentionally designing our layers and team interactions using the inverse Conway maneuver, brings us to a fundamental insight about leadership in modern tech organizations. Ray Dalio captures it perfectly. Understand that a great manager is essentially an organizational engineer. This is the key message. We've seen how team structures, boundaries, and communication pathways directly constrain or enable our technical architecture and our ability to deliver value quickly. This deep interdependence highlights that we are always working within socio-technical systems, where the social aspects, teams, culture, communication, and technical aspects, architecture, tools, are inseparable and must be designed holistically. Therefore, shaping the organization, designing the team of teams, isn't just an HR function. It's a critical engineering discipline, a form of socio-technical design with profound technical consequences. So, if applying Team Topologies principles and the inverse Conway maneuver seems like the logical way to break free from being stuck in the middle and achieve fast flow, why is it often so hard for organizations to get started? From a manager's perspective, restructuring teams is inherently complex and often perceived as risky. It disrupts established routines, reporting lines, budgets, and sometimes even challenges existing power structures or fiefdoms. It requires not only understanding organizational dynamics, but also grasping the deep connection to technical architecture dictated by Conway's law. Getting buy-in across different parts of the organization can be difficult, significant investment might be needed, and the immediate return isn't always easy to measure. Furthermore, managers might lack the explicit mandate or feel hesitant due to past experiences with painful, ineffective reorganizations. This iterative, hypothesis-driven approach, focusing on clear boundaries and interaction modes like those in team topologies, contrasts sharply with the often disruptive top-down orgs of the past. However, successfully applying this iterative maneuver depends heavily on supportive conditions like psychological safety, allowing teams to experiment and learn without fear of blame. Strong leadership commitment that champions the change beyond just line management, building trust across teams, and embracing organizational design as an ongoing adaptive process. While these cultural elements are crucial, the relationship works both ways. Intentionally designing team structures and interactions for clarity and reduce friction, as advocated by team topologies, can itself help foster trust and a more collaborative culture over time, provided leadership actively champions the evolution. It's important to note, however, that while traditional managers often hold the formal authority for organizational change, the work of organizational engineering doesn't have to fall solely on their shoulders. This analysis, design, and facilitation can also be driven by specialized groups, perhaps akin to an enabling team, as described in team topologies, who are tasked with guiding and supporting the organization's evolution towards more effective structures. One more thing. We've spent this whole time talking about Conway's law and how crucial the inverse Conway maneuver is for designing effective organizations and enabling flow. But what if the very foundation we've been discussing isn't always the most useful starting point for the conversation? We've established the power of the inverse Conway maneuver as a tool for organizational engineering, but is explicitly talking about Conway's law always necessary? Recently, Matthew Skelton, co-author of Team Topologies, reflected on LinkedIn that he hasn't really needed to explain Conway's law for the past couple of years when discussing the value of team topologies, especially with senior executives. He argues that the core team topologies principles, like focusing on flow without handoffs, staying close to the customer, and using cognitive load as a design principle, are often more direct and compelling arguments for change on their own. Interestingly, just a few years prior, in 2022, his co-author, Manuel Paes, gave a presentation titled Conway's Law is Out to Get You, highlighting how central it was to the conversation then. So, the emphasis seems to be shifting. As I suggested in my reply to Matthew's post, perhaps Conway's Law is becoming less of a foundational requirement and more of a useful storytelling tool. What are the pros and cons here? Pro, talking flow directly. Focusing purely on principles like eliminating handoffs, reducing cognitive load, and improving flow might be more direct, practical, and relatable for certain audiences. It avoids potentially academic discussions about a decades-old law. Con, losing the narrative. However, ignoring Conway's Law means losing a powerful explanation for why existing siloed structures often lead to tangled, inefficient systems. For teams suffering from the effects of accidental Conway mirroring, like ticket ops behind the facade, invoking the law can be an aha moment, clearly framing the problem and justifying the need for intentional redesign based on team topologies. Ultimately, the goal is designing for fast flow. Whether you explicitly use Conway's Law to make your case might depend on your audience and the specific pain points you're addressing. The underlying principles of reducing handoffs and managing cognitive load remain paramount. So, if talking directly about Conway's Law isn't always necessary, how can we pragmatically start the conversation about improving flow? One extremely effective way is by focusing directly on team dependencies. Look at this simple but powerful tool suggested by Team Topologies, Team Dependencies Tracking. It involves systematically identifying and documenting which team depends on which other team. What is the nature of that dependency? Is it blocking progress entirely? Is it just slowing things down? Or is it a healthy, well-managed dependency marked as OK? Does the dependency cross different value streams? And what exactly is the dependency? Is it waiting for an artifact, an approval, some specific knowledge, or something else? This approach is incredibly pragmatic. Instead of starting with theoretical laws or abstract organizational models, you focus on the concrete, day-to-day friction points that are actually hindering your teams. Where are the bottlenecks? Where are the handoffs causing delays? By mapping these dependencies, you create a clear, data-driven picture of where flow is being impeded. It provides tangible evidence and shifts the conversation towards specific, actionable problems. Furthermore, this tracking provides exactly the kind of data you need for those leading indicators we discussed earlier when framing organizational changes as testable hypotheses. It gives you concrete evidence of whether your interventions are actually reducing friction. And notice, we haven't needed to mention Conway's Law at all. We're simply identifying and analyzing the real obstacles to getting work done efficiently. Once we've mapped out those dependencies using the tracking method from the previous slide, what do we do with that information? Team Topologies provides clear guidance. Eliminate blocking dependencies. Mitigate slow dependencies. Keep healthy dependencies. This is a direct, action-oriented approach focused squarely on improving flow. By systematically identifying and then actively working to remove or reduce the friction caused by these inter-team dependencies, you are directly tackling the bottlenecks. You're clearing the path for work to move more smoothly. This focus on minimizing handoffs and delays achieves the goal of faster flow, fulfilling a core principle of team topologies. And as Matthew Skelton suggested, You can achieve this outcome without explicitly invoking Conway's law. The practical actions speak for themselves. However, understanding why those blocking or slowing dependencies exist in the first place can be crucial for advocating for more fundamental change. Often, the root cause isn't just a missing tool or a poorly defined process, it's the organizational structure itself, the legacy silos. This is where referencing Conway's law can still be incredibly useful. Think back to our Wizard of Oz metaphor. Those blocking or slowing dependencies are often the clumsy actions of the man behind the curtain. The manual handoffs, the ticket queues, the coordination meetings necessitated by a fragmented team structure. Conway's law helps explain why that man behind the curtain structure exists and why it inevitably creates these kinds of inefficient interactions, mirroring the organizational silos in the system's workflow. So, while you can improve flow by simply tackling the dependencies you find, using Conway's law as a narrative tool helps make the case for a more sustainable solution. Applying the inverse Conway maneuver. It explains why restructuring towards well-defined team types and interaction modes, like those in Team Topologies, is necessary to permanently eliminate those blocking dependencies rather than just patching over the symptoms. It provides the why behind redesigning the organization to build the fast-flowing system you need, ultimately reducing the hidden costs of friction and delay inherent in the old structure. And that brings us to the end of our bonus exploration into the inverse Conway maneuver. We started with Conway's law, understanding how our team communication structures inevitably shape our system architectures. We saw how fighting this law leads to friction and obstacles, often keeping teams stuck in the middle. Then, we flipped the script, exploring the inverse Conway maneuver, intentionally designing our organization to enable the architecture and fast flow we desire. We looked at managing the responsibility knowledge paradox, the role of different layers like IaaS, PaaS, and IDPs in offloading cognitive load, and how frameworks like lean value trees can guide organizational engineering as a testable hypothesis. We even questioned whether explicitly mentioning Conway's law is always necessary, highlighting pragmatic approaches like dependency tracking. The core takeaway, as Martin Fowler emphasized, the key thing to remember about Conway's law is that the modular decomposition of a system and the decomposition of the development organization must be done together. Designing our teams is designing our systems. Great managers or dedicated enabling teams act as organizational engineers, shaping the team of team structure to unlock fast flow and developer productivity. Whether you're battling the man behind the curtain or building a reliable vending machine and paving the yellow brick road, intentional organizational design, managed iteratively and focused on reducing friction is paramount. Thank you so much for joining me. I hope this dive into organizational design for fast flow was insightful. What are your experiences with Conway's law or applying the inverse Conway maneuver? Let me know in the comments below. Don't forget to check out the other videos in the Platform Engineering series if you haven't already. See you next time. Thank you for sticking around to the end. The remainder of this video contains an overview of all resources used. There's some great stuff out there, often with references to even more great stuff. Are you ready to go down this rabbit hole?